Many measurements that we have in science are either very, very large or very, very small. And so scientists have developed a kind of notation, a shorthand way to write down measurements. And because we primarily use it just in science, it's called scientific notation, a shorthand way of writing these big or small numbers. And it's based on the power, or base 10, powers to the base 10. And so if I have a couple of examples here, you'll see here is the mass of the Earth in kilograms, and that's a really big number. And of course, we don't want to write that number out all the time, so we write that number instead in scientific notation. Now, that's a very big number. But the next number is the wavelength, how long a X-ray is in centimeters, and you'll notice that's a really small number. So we can use scientific notation to write big numbers or small numbers in kind of a shorthand method. And the standard form of scientific notation is right here, N, and N, you'll see right here, is a number, an integer between 1 and 10. And actually, I shouldn't say an integer. It's any number between 1 and 10. I can't use like 0.8, and I can't use 11, but I could use something like 2.2 or something like that, because that's between 1 and 10. Times 10 to the k power, where k is an integer, and k can be either positive or negative. If you're going to have a number like, or a measurement like the mass of the Earth here that's greater than 1, you're going to have a positive k value. If you have a measurement that's less than 1, you're going to have a negative k value. So I could write certain, for I guess the mass of the Earth, if we want to write that one, we see that it's 6 and then a whole bunch of zeros. So we start always on the left side of the measurement, and the first digit we write down is the first significant digit we come to, and of course that's a 6. And then what we'll do is we'll count how many digits there are behind that. So I do it in threes. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8 is 24. So it would be 6 times 10 to the 24th kilograms. That'd be a proper way to write it. You might see people do things like this, like they might do 60 times 10 to the 23rd kilograms. Well, although that is actually the same number, that is not proper standard form for scientific notation, so that will not be correct. Sometimes the math people like to mess around with stuff like that, but this is scientific notation, so we trump the math department. So this integer or this n value out here needs to be something between 1 and 10. Always keep it that way. So this first thing would be 6 times 10 to the 24th. Now look at this next one here. I still start on the left side and I go all the way over till I get to my first significant digit, and that's a 9, but then there's another one behind it, 9.5. So I'm going to do 9.5. That's where I'm going to move the decimal to. And I need to count how many digits I move the decimal over. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and then I put the decimal behind the 9, so I count the 9 also. So that's 6, 7, 8. I moved it over 8 times. Now this number is less than 1. So when I do times 10 and I put the 8th power on there, I'm going to have it be a negative 8. So if your number is less than 1, you're going to have a negative exponent. So 9.5 times 10 to the minus 8 is what I have there. Now in my classes, instead of the times 10, we're not going to write the times 10 part. Instead of times 10, we're going to write the letter E. So the mass of the Earth we could write, like in an E-lab, 6 E 24 kilograms. And the length of an X-ray we could write 9.5 E negative 8 centimeters. So instead of times 10 in an E-lab, it's kind of hard to write that. we're going to write a capital E instead of the times 10. So you just need to realize that's what that means. 6 times 10 to the 24th power. Okay, let's do a couple problems here. Let's say I have this as a measurement, 1060. And I want to write that in scientific notation. And I want to retain, you always want to retain the correct amount of sig figs. So you'll see that this one here, if you do Pacific Atlantic, it has 3 sig figs. So I want to write this measurement in scientific notation, retaining all 3 of the sig figs. So we always start, of course, on the left side, and we go to the right, and we come to the first sig fig that I find is the 1. So I'm going to write down 1, but I need the 0 and the 6 are also significant. So I need to include those in there. So I'm going to write 1.06. So times 10 to the, how far did I move the decimal point over? Well, the decimal point, although there wasn't one you can really see here, technically is like right here. So 1, 2, I moved it over 3 spots. So 1.06 times 10 to the third. So anytime you have a number or measurement that's in the thousands, that's always going to be 10 to the third power. Measurements in the hundreds will be 10 to the 2, and so on. So this would be 1.06 times 10 to the third is the way to write this measurement in scientific notation. You need to retain your correct sig figs. Let's try another one. Let's take this measurement here, 0.00210. I'm going to write this in scientific notation. You'll notice this measurement is less than 1, so my exponent is going to be a negative exponent. And you'll see that I have, if I do Pacific Atlantic, this one, and this one are all significant, 3 sig figs. So I need to retain all of those. So I'm going to move the decimal 1, 2, I'm going to put it right behind the 2. So I'm going to move it 3 places. So my answer is going to be 2.10, because I got to keep those significant digits, times 10, and I moved it over 1, 2, 3 places. This is less than 1, so it's going to be a negative exponent, minus 3. 2.10 times 10 to the minus 3. Or in an ELAB, I could write 2.10 e minus 3. You can do it that way also. All right, let's do another one. 2400. I want to write that in scientific notation, keeping the correct amount of sig figs. So you'll see that the 2 is significant and the 4 is also significant. The 4 is my estimate. So I need to retain those. So I'm going to write 2.4 times 10, and the decimal was technically over here, so I went 1, 2, and I put it right there. So I moved it 3 spots. This is greater than 1, so it's going to be a positive exponent. 2.4 times 10 to the third would be how I would write this measurement. Now let's say that I get 2400 on a calculator, but I know when I did the math that this 0 is actually supposed to be significant. So how would I write this in scientific notation to show that that 0 is significant? Well, all I would have to do is I'd write 2.40. I'd have to go ahead and include that 0 in there, because all these digits in the end position, they're all going to be significant. And scientific notation is the best way to write these things, because you don't really have to worry about sig figs. Everything in the end spot is going to be significant. So that's how I could write 2400 in scientific notation if I wanted to show that there were 3 sig figs. We'll do one last one. Let's say I have 0.052. I'm going to write this in scientific notation. You'll notice there's 2 sig figs. The 5 is significant, we know it, and the 2 is an estimate. So, and this is all less than 1, so my exponent is going to be a negative something. So I take the decimal and I moved it 2 positions. So I'm going to write 5.2. I want to retain the sig figs. And I moved it 2 positions, so it's 5.2 times 10 to the minus 2 is where I moved it. Let's say on this one, though, we know that when we do the math, this is what the calculator gave us right here, but we know that there's actually supposed to be 3 sig figs. 3 sig figs. Okay? So that means there's another 0 on here. The calculator didn't show it, but we need to show that there's another 0 on here because that's actually our estimate. So it's 0.0520 would be 3 sig figs. So how do I show that in my scientific notation? Well, again, I just would include the 0 there. So 5.20 times 10 to the minus 2 would be a way to write this measurement with 3 sig figs. So hopefully that'll help you out. By the way, I could also then write this like in an ELAB, 5.20e negative 2. I can write an e instead of the times 10. So hopefully that helps you know how to write scientific notation.